So we're going to look at the equations of parallel and perpendicular lines. So first, let's look and remember back to Algebra 1. Slope-intercept form is y equals mx plus b. M is the slope. B is the y-intercept. B is the y-intercept. Then there's point slope form, which is y minus y1 equals m, x minus x1. Again, m is the slope. The point are these little x's and y's with little number ones, x1 and y1. That's the point that you know about the graph. And slope is y2 minus y1 over x2 minus x1. So if you know 2 points, you just plug it into the formula. Sometimes you also think of it as rise over run, or the change in the y over the change in the x. That's slope formula. So we're going to be using those all throughout the lesson and how it's going to tie into parallel and perpendicular. So parallel lines, remember, they are two lines that never intersect. They won't cross, they won't touch. They're in the same plane, but they will never intersect. So parallel lines do not intersect. Right, never intersect. This is kind of a note right here. Parallel lines never intersect. So when you're talking about lines that you graphed that never intersect, they have to have the same slope. The only way that they won't intersect is if they have the exact same slope. So if we're going to be parallel to y equals 5x plus 1, it has to have the exact same slope as y equals 5x plus 1. So the slope here is 5. So the slope of the parallel line has to stay the same. It's got to be 5. We're going to use the slope 5. And we're going to use the point -1, comma 2. Since we have the slope and a point, we're going to use point slope form to get us started at least. So we will go y minus the point from, or the y from our point, which is 2, equals m, which is 5, and x minus whatever the x is from the point. So minus -1 is plus 1. It tells us we have to write it in slope-intercept form, so the easiest thing to do is just distribute and move the 2 over. So distribute that 5. Now move the 2 over, so we'll add 2. So there's the equation in slope-intercept form. So we'll do the same thing here. If we're parallel to y equals -3x plus 4, we're going to keep that same slope. Parallel means keep the same slope. So the slope that's going to be in our new line is going to be -3, because that's the slope in the given line. And if it passes through the point 9, -6, we're going to use that point in point slope form. So we write y minus -6, so y plus 6, equals m x minus the x number, which is 9. Distribute. And then we will subtract the 6 over. And there's the equation for the parallel line that goes through 9, negative 6. So if you're going to write the equation for a perpendicular line, you just have to know the slope relationship for them. And perpendicular lines have slopes that are opposite reciprocals, which means the fractions are flipped and there's one positive and one negative. So you flip the fraction and you change the sign. Another way that sometimes that's written is that the slopes will multiply to equal -1. It's not a bad thing to use to test, but it's a difficult thing to apply to the given problem. So if we're going to be perpendicular, remember perpendicular also means that they intersect at a right angle. So if you're going to be perpendicular, you have to have an opposite reciprocal slope. So we have to know the slope that's here for the given line, which is 4. Or you could think of that as 4 over 1. And then to get the perpendicular slope, you're going to flip it to get the reciprocal. So instead of 4 over 1, it's 1 over 4. And then opposite means you change the sign. So since this was a positive slope, the perpendicular is going to have a negative slope. So positive change to negative, 4 over 1 change to 1 over 4. And then again, we're going to use the point that they give us, 3, -1. And we'll use that to write our point slope, and then we'll convert it. We do y minus the y value, so y minus -1 turns to y plus 1. And then our slope, x minus 3. Then we distribute, so -1/4 x. Negative times negative is positive, and then you multiply numerator times numerator, top times top, and denominator times denominator, bottom times bottom. So you get 3 over 4 times 1 is 4. And then to get y by itself for slope intercept, we have to subtract the 1. And a little bit of fraction work. Since we wanted to have a denominator of 4, we're going to change that 1 to be 4 over 4, because that's the same thing. And you just subtract the numerators. 3 minus 4 is -1. And you keep the denominator. So for this next one, the line's perpendicular to y equals -2 over 5x plus 12. So we're going to take that slope. Since we're doing perpendicular, we need to get the opposite reciprocal. So we're going to flip the fraction and change the sign. So 2 over 5 flips to be 5 over 2. And you change the sign from a negative to a positive. So there's the slope for our perpendicular. Positive 5 over 2. And then we use the point -6, -8. Plug it into point slope, so y minus the y value So y minus negative 8 is y plus 8. And then the slope, 5 over 2. And then x minus the x number. So x minus negative 6 turns to x plus 6. And again, distribute. Six over 1, you multiply top to top, numerator to numerator, denominator to denominator. 5 times 6 is 30 over 2. Thirty over 2 is 15. So now when we solve for y to get slope intercept, we subtract the 8. (15 minus 8 is 7. So there's our perpendicular line that goes through the point of these holes.